Hello everyone. In my previous video we have seen about equality of complex number. So the link is above in the iCard. So you can watch that video for equality of complex number. Okay. Yeah. So in this video let us discuss about addition of complex number. So in algebra of complex number, we have four basic operations. So first one is addition, and the second one is difference, which is nothing but subtraction. Third one is multiplication. And fourth one is division. So these are the four basic operations. So now in this video let us discuss about the addition of complex numbers and properties of addition. Okay. So let me start. So let me take two complex number. So let Z1 be one number and Z2 be the other number. So let me take Z1 as Z1 is equal to A plus IB. So let me take Z1 as A plus IB and Z2 as C plus ID. So these are the two complex numbers. Now the sum, which is nothing but the addition of these two complex number, which is represented by Z1 plus Z2, is defined as Z1 plus Z2, which is equal to A plus C plus I into B plus D. So after adding two complex number, we will be getting again a complex number. So the sum is also a complex number. Now how to find the sum? So you just need to add the real parts. Now in Z1, what is the real part? In Z1, A is the real part. In Z2, what is the real part? C is the real part. So let us add those two. So it gives A plus C plus I into what is imaginary part? So B and D are imaginary parts and the numbers, complex numbers. So let us add those. So the addition of complex number says that according to addition of complex number, if Z1 and Z2 are two complex number, we can add it easily such that Z1 plus Z2 is equal to A plus C plus I into B plus D. Okay, and the sum also gives us a complex number. So let us take one example. So let me take Z1 as 2 plus I3, a simple example, and Z2 as minus 6 plus I5. Okay, so what is now the sum? That is nothing but Z1 plus Z2. So Z1 plus Z2 is, so if suppose I compare this with A plus IB, which we have taken in general format, A plus IB, A is 2. So which is nothing but the real part of the first number plus the real part of the second number. So it is minus 6 plus I into imaginary part of the first number plus imaginary part of the second number. So be careful with the signs. So we have to consider the general format of the complex number is in this format. So with respect to this, we have to take the polarities or the signs of the numbers. Okay, signs of the numbers. So here it is positive 2, that is plus 2, and here it is minus 6. So we have considered this. So the answer here is minus 4 plus, and what about this? Both are positive, so I can simply add them. So it gives us 8. So the complex number, two complex numbers are added, and the sum is minus 4 plus I8. So the sum is this. Okay. Similar way we can take any examples. Let me take a few more examples for addition of complex numbers. So let me write Z1 as, let me take Z1 is equal to minus 6 plus 3j and Z2 is minus 7j. Okay, both are complex number. So now the sum will be Z1 plus Z2 is equal to, real parts we should add it first. So the real part here is minus 6, whereas the real part here is 0, which is not there. So we can just say it is minus 6 plus 0, or simply you can write minus 6 plus I into, so this is I, or you can represent it in j also. Let me write it as I. So yeah, I into the sum of imaginary parts. So it is 3 here in the first number, and the second number, the imaginary part is minus 7. So here this gives us minus 6, and this 3 minus 7 is minus 4. So it gives us minus 4i. So this is the addition of Z1 and Z2. So let me take one more example. So let Z1 is equal to 5. Z2 is equal to minus 3i. So this is a complex number. Though there is no imaginary part, we have already taken real number as a subset of complex number. So we can treat real number as a complex number. So Z1 is equal to 5 where there is no imaginary part, and Z2 is equal to minus 3i where there is no real part. Okay, so this is known as pure real, imaginary number. So this is known as pure real number. Okay, fine. So let us find out now Z1 plus Z2. So Z1 plus Z2 gives us real parts we have to add first. So in the first number 5 is the real part, in the second number there is no real part, so it is 0. So 5 plus 0 is 5 plus I into first number has no imaginary part in it, but the second number has imaginary part in it, that is minus 3. So 0 minus 3, so it is minus 3. So the result is, which is nothing but the sum of two complex number is 5 minus 3i. So I hope that's clear for you. Now let us see the properties of complex number addition. So let us write the properties. So properties of complex number addition. So first one is the closure law. So according to closure law, or according to this property, it says that the sum of two complex number is always a complex number for all complex numbers Z1 and Z2. So let me repeat it. According to the property, that is closure law, it says that the sum of two complex numbers is a complex number for all complex numbers Z1 and Z2. So let us take Z1 and Z2 as two complex number. Then if Z1 and Z2 belongs to complex number set, then the sum which is given by Z1 plus Z2 is also a complex number. So it should belong to the set of complex numbers. Okay. So we have seen many examples previously for addition. So where we have seen when we add two complex number, the result, which is nothing but the sum, is also complex number. So this is nothing but the closure law. So second is, let us see the second property. So the second property is the commutative law. So the second property is the commutative law, according to which it says that for any two complex numbers Z1 and Z2, if you write Z1 plus Z2 or if you write Z2 plus Z1, the resultant will be same. So it says that the order of the numbers in the addition is not at all important. So you can write Z1 plus Z2 or you can write Z2 plus Z1. So the resultant will be same. So let us take an example. So let me write Z1 is equal to 3 minus 2i and Z2 is equal to minus 2 minus I. Okay. Now let me calculate Z1 plus Z2. So Z1 is 3 minus 2i plus Z2 is what? It is minus 2 minus I. So let us add this. So we have to first add the real numbers. So it is 3 and here it is minus 2 plus I into imaginary part we have to add. So here the imaginary part is minus 2. So minus 2 and here the imaginary part is minus 1. So minus 1. So what is the answer you are getting? So it is 1 plus I into minus 3, or I can write it as 1 minus 3i. So this is the result we got from Z1 plus Z2. Let me write Z2 plus Z1. So I am reversing the order of the complex number. I am adding two numbers. So what is Z2? Z2 is minus 2 minus I plus what is Z1? Z1 is 3 minus 2i. Now let us add the real part. So it is minus 2 and here the real part is 3. So it is plus 3 plus I into the imaginary parts you add. So what is the imaginary part here? It is minus 1. And what is the imaginary part here? It is minus 2. So let us add. So what you are getting? So this is 1 plus I into this is minus 3. So you are getting 1 minus 3i. So this according to commutative law, you can see the answers are same. So you write Z1 plus Z2 or you write Z2 plus Z1. Both gives us the same answer. So this is nothing but the commutative law. So this law holds good for real numbers also. We have seen this law in real number set. So the same holds good for complex number also. So we have seen closure law, we have seen commutative law. Next we'll see the associative law. So according to the associative law, it states that for any three complex numbers Z1, Z2 and Z3, so you group it in any way. That is nothing but, see, you can see here on the LHS side. So I have grouped and added Z1 and Z2 first. So it is Z1 plus Z2 and the result of Z1 plus Z2 is added to Z3. And you can group Z2 and Z3 first, then the result can be added to Z1, but the answers will be same. So this is nothing but the associative law. So you can take any example and you can write, you can verify this law. So take three numbers Z1, Z2 and Z3 and you group first, you can add first Z1 and Z2, then the resultant you can add it with the Z3. Similarly, you can group Z2 and Z3 first, that is nothing but you add Z2 and Z3 first, then the answer you add it with Z1, you will be getting the same answer. So this is the associative law. The next one is the existence of additive identity. So the existence of additive identity is nothing but, see, there exists, let me write it first. So there exists a complex number 0 plus I0. So if you write 0 plus I0, this is nothing but 0. So this is denoted as 0, called the additive identity. So 0 is called the additive identity or the 0 complex number, such that for every complex number z plus 0, which is nothing but additive identity, it will give z itself. So let me take one example. So let me take z as 1 plus I, which is a complex number. Now let me add 0 to this. So z plus 0, which is nothing but 1 plus I plus 0. So what you are getting? You are getting the same number itself, which is nothing but the z. So here the 0, which can also be represented as 0 plus I0, is known as the additive identity of complex number. So if suppose it is asked, what is the additive identity of complex number? It is 0, or you can also write it as 0 plus I0. Next one, fifth property is the existence of additive inverse. The existence of additive inverse. So fifth one is, so according to this property, which is nothing but the existence of additive inverse, so to every complex number z is equal to a plus ib, we have the complex number minus a plus I into minus b denoted by minus z, called the additive inverse or negative of z. Okay. So, each and every complex number has additive inverse, which is also called as negative complex number. So, how it will be? So, if z is a complex number, then minus z will be the negative of a complex number. So, how to represent? If a plus ib is the given number, then the negative of this or the additive inverse of this can be written as minus a plus I into minus b. Both the real and imaginary part numbers will change its sign. Okay. So, that gives us the negative complex number such that it should satisfy the condition. So, what is that condition? So, when we add the complex number with its negative, it should give us the additive identity, which is nothing but 0. So, it says that the complex number plus the negative of the complex number, it should give us the additive identity. So, what is the inverse, additive inverse here? So, this is called the additive inverse of the complex number. So, let me take one example. So, if z is equal to minus 3 plus 2i, then minus z is equal to, I have to change the sign of real and imaginary part numbers. So, here it is minus 3. So, let us write it as plus 3. Here it is minus plus 2. Let us write it as minus 2. Or it is simply minus of z. So, this is z. So, what is minus of z? So, minus of z. So, let me write this inside. So, it is minus 3. Sorry, it is minus of z. So, z is minus 3 plus 2i. So, minus minus it becomes plus, minus plus it becomes minus 2i. So, it is 3 minus 2i is the negative or additive inverse of minus 3 plus 2i. Let me take one more example. Let me take z as 2 minus 2i. So, negative inverse or additive inverse of this number is minus of z, which is nothing but plus 2i. Okay. So, this is about the existence of additive inverse. So, we have seen all the properties of complex number addition. So, that is it for today. So, the remaining operations, which is nothing but difference, multiplication and division, let us discuss in the next videos. Okay. Subscribe my channel. Please share the videos, like the videos and comment if you have any. Okay. Thank you. That's it for today.